Looking over the exit slips from yesterday's assignment, which was that 9.2 practice worksheet on ellipses, I noticed there were a couple questions. So I figured I would do problem number 10, and hopefully as I complete problem number 10, that will answer some of the questions you might have had. Now, in this question, you were asked to find your center, your vertices, your foci, and the eccentricity of the ellipse. So we're going to talk about how we can take it from this format, shuffle it back to our standard equation so that we can identify all of those key characteristics. Okay, so to get started with the standard form, what you want to do is take the general equation that we see here and regroup it so that all of your x terms are together, which they've already done for you. All of your y terms are together, which they, again, have already done for you. And then if there were any numbers here, you would subtract them over to the other side. And again, they've already taken care of that for you. So we're at a pretty good spot. Now, to get the equation for our ellipse in the standard form that we like, what we need to do is complete the square so that we can get this to be x plus or minus some number, that quantity squared over some value, plus then y plus or minus some number squared all over some value equal to 1. So we're going to start by factoring out the leading coefficient of whatever's in front of the x squared first. So in this case, it's our 16. And if I divide this by 16, it's going to leave me with x squared. I'm going to keep my minus sign. 32 divided by 16 is going to give me 2x. And now I need to complete the square in here. And again, to do that, we look at our middle term, take half of it, and square it. So half of 2 is 1. 1 squared is 1. So I'm going to put a plus 1 in here. Now, when I go to the other side to balance my equation, I'm not just adding 1, because I have 16 of these groups here. So I want to make sure when I balance my equation that I take that 16, multiply it by the number I put in there, and that's what I'm going to add to my other side to balance my equation. So I'm going to add 16. Looking at this piece, I'm going to take 25, factor that out because that's the leading coefficient of my y squared. That'll leave me just y squared. Keep my plus sign. 50 divided by 25 is 2. And again, complete the square. I'm going to take half of 2 and square it, which is again 1. And again, when I complete the square here, I've not just added 1, but I added 25 of those groups of 1. So I'm going to multiply those, and I'm going to add 25 over to that side. So now to finish up the problem, I'm going to finish the process for completing the square. This now created perfect trinomial squares, so I'm going to factor them. So I'm going to get 16 times that quantity of x minus 1 squared plus 25 times that quantity of y plus 1 squared. And if I do the math over here, that leaves me with just 25. Now, in our equation for our ellipse, there's two things that we need to have happen. We want to make sure that neither of these have a leading coefficient, and we want to make sure the right side is equal to 1. So when we get a number over here that's not 1, we divide both sides by whatever number that is so we can make the right side equal 1. So in this case, we're going to divide both sides by 25. Now, what ends up happening is if I try to reduce, 16 over 25 doesn't reduce. But when we write our equations for the ellipse, we always want the numerators to have coefficients of 1. So if I want to reduce this fraction, what I need to do to get that coefficient of 1 is divide the numerator and the denominator by 16 so that I can make that numerator become 1. And so I'm going to get that quantity of x minus 1 squared, and my denominator now is going to be 25 over 16. Normally we don't like fractions within fractions, but for this problem we're going to go with it. Over here, I'm going to take that y plus 1 squared, and I'm going to divide the numerator and denominator by 25, and that's going to leave me just 1. And that right there would be my standard form for my ellipse. So that was the first thing the question asked us to do. And it's pretty obvious now that that's in standard form that our center is those values for hk. So our center is going to be positive 1, negative 1. Now, in order to find the remaining pieces, in order to get our vertices, our foci, and our eccentricity, we're going to need those values for A, B, and C to help us finish that problem. So remember, when we're looking at our denominators, a squared is always the bigger number. So 25 divided by 16 is some number bigger than 1. So I know that a squared is 25 over 16. And if I take the square root of both sides, that tells me a is 5/4. And then in this denominator, b squared is 1. And if I take the square root of both sides, b is 1. These are used to find my vertices and my covertices. To find my vertices, I'm going to use my a value, because remember, our vertices are a units in each direction from our center point. Our covertices are b units in each direction from our center point. And to figure out which coordinate you change, you look at which coordinate those values were attached to. So notice my a value was attached to my x. So when I go to find my vertices, since a squared was under x, that told me that this was a horizontal major axis. Because my x coordinate on my x coordinate plane would go across. So it's a horizontal major axis. So when I go to find my vertices, I'm going to take my x coordinate from my center, and I'm going to add and subtract that 5/4 to get my vertices to that x coordinate. So I'm going to get 1 plus 5/4, -1, and 1 minus 5/4, -1. And if we simplify that, that would be 9/4, -1, and -1/4, -1. So those would be my vertices. To get my covertices, I use my b value, and my b value this time was attached to my y. So I'm going to go back to my center point, and I'm going to add and subtract my b value to my y coordinate for this one to find my covertices. So this time I'm going to take -1 plus 1 on my y coordinate, and I'm going to keep my x coordinate and then do -1 minus 1. So my covertices are going to be 1, 0, and 1, -2. Now, the last thing it was asking you to find were your foci and your eccentricity. Your foci and your eccentricity both rely on the value for c. So I need to work through and actually find my value for c before I can answer those questions. So remember, c squared is equal to a squared minus b squared. And if you always make sure you remember that a squared is your bigger number, this will always be easy to work out. So I'm going to take 25/16 minus 1 for my a squared and my b squared value. If I work that out, c squared is going to be 9/16. And then when I take the square root of that, c is going to be 3/4. So my foci are 3/4 units away from my center. All right. Now remember, our foci line up along our axis. So again, this had a horizontal major axis, which means that my center, my vertices, and my foci are all going to transform with the x. We're going to move left and right to get those pieces. So we're going to basically, to find our foci for this graph, we're going to take the x coordinate of our center, and we're going to add and subtract our c value from that x coordinate. And then once I have that, I can just simplify that. So this would be 7/4 -1, and this would be 1/4 -1. So those would be my two foci. And then last but not least, to get our eccentricity, you learned a new formula that eccentricity is the value for c divided by a. And we just found out in this problem that c was 3/4, and a, when we worked it out up here, was 5/4. When we have a fraction divided by a fraction, we can simplify that. If you think back, you change division to multiplying by a reciprocal or keep change flip. So that would be 3/4 times 4/5, which would work out to be 3/5 or 0.6. Okay, so those are the key things to keep in mind. If my a squared value, if my bigger number was under the y, then I would have transformed the y coordinate of my center from my vertices and my foci by adding, subtracting a to the y coordinate, and then adding, subtracting c to the y coordinate. And then my co-vertices, the b would have been attached to the a. The b would have been attached to the x value, so I would have transformed that. So it's always determining which axis you have. That's going to help you decide whether you should be changing your x's or the y's. And again, I always just think about it. In this case, a was attached to x, so I'm going to add or subtract a to my x value. B was attached to y, so I'm going to add or subtract b to my y value. And C always follows the pattern of A. So C would change my x coordinates in this graph in order to find my foci. Okay? If you still have any questions, let me know.